So, okay, so I hope this is clear. We're doing an application of something that's slightly advanced or intermediate in the hope that this is going to motivate us or give us a look on how these fundamentals get implemented at the end. Okay. Uh, Now I want to talk about something else. Uh, and trust me, just 5 minutes of talking or 10 minutes of talking. We're gonna start now. What is so like interesting about cybersecurity? Okay, if we come, let me come here actually. Okay, and I'm gonna say that the fact. Would you think that hacking is an easy topic or is it a difficult topic?
Difficult topic.
Okay, and I would say that other than being difficult, what's very interesting about it is right now at this instance, that's you. You're physically connected to a top, like the servers of a major bank. Okay. At this instance, you are physically connected to the physical servers. You're physically connected of a major governmental entity. You're probably connected to the FBI physically. All of this, you're actually physically connected. But the only thing that's stopping you from gaining access to any of these, okay, is what? It's a logical limitation. So it's something that's logical, something that is software, something that's abstract, that's stopping you from gaining access to any of these. Okay. So in physical security, you're literally like, no, you're not connected physically to any FBI place or any governmental entity or any bank. No, there's physical controls, physical things. There are walls, there are mitigations to prevent you from gaining physical access. But what's interesting in cybersecurity, because it's cyber, is the fact that you are physically connected. Okay. And if you knew how to bypass these logical controls, there's nothing stopping you from accessing any of these. So there's nothing stopping you from gaining access to that bank. There's nothing stopping you from getting access to, and actually not just you, like malicious, like it goes all the way. So anyone in the world, they're physically connected to so many high stake assets and resources, and the only thing stopping them from gaining that access is logical controls. So now, how do we bypass these logical controls? Okay, and the question goes both ways. How can we ensure that even though the top hackers in the world or the top malicious people in the world or maybe like other countries, they're physically connected to our resources, they're physically connected with each other, how can we ensure that we're able to put the right logical controls that prevent a malicious entity from gaining access to our stuff, even though it's all physically connected. Okay. So this is a tricky question because if logic is used to protect, it could be bypassed. Logic is fallible. It could have vulnerabilities. It could have things that allow someone to bypass that logic. Okay, and how can we know whether this logic is bypassable or not? That's what we're doing right now. It is security research. It is taking that logic, whether it's a network logic, whether it's a web application logic, whatever it is, and analyzing it, looking at it, researching it until we're able to bypass it, or the other way around. We look at controls and defenses and logical ways we can use to protect ourselves and put safeguarding mitigations in place that prevent anyone else from abusing that logic and gaining access to our resources. So, and I find this very, very fascinating. We're all connected, and it's all about logic. Now, let's take this a step further. This logic, if we're now talking about logic, then it's now becoming a knowledge or like mind versus mind. Okay, so it's turning into, now we have someone who is very, very knowledgeable, and this person is putting safeguards in place. They're putting mitigations, very advanced mitigations. And there is another person, maybe that's should have made that one blue. There's another person who is maybe more or less knowledgeable, and they're able to put or bypass that logic in their own ways. So now it's becoming a human versus a human, a mind versus a mind. And it's very competitive, in software development, for example, in software engineering. You're not really competing against anyone. You're building a product. Okay, you're building a product, and there's a set of requirements a client asks of you. Okay, and you just build a product that matches these requirements. Okay, and that's it. But in cybersecurity, that's not the case. It's more open-ended. If you're protecting or if you're attacking, like whether maliciously or attacking for the sake of protection and identifying vulnerabilities, you're working against another human, another mind, who's possibly more intelligent or more knowledgeable than you. And it becomes that kind of competition between blue and red, and everyone is trying to improve their, you know, bypass each other. Um, does that make sense? Okay. Yes, Adil. Go ahead.
Sorry, I meant React. Sorry.
Okay, go ahead. No problem. So now, why am I doing this? I'm saying this to show you that this is really, really fascinating. It's also very, very challenging. So it's something that is unlike other disciplines. It's not like software engineering. It's not like maybe system administration. It's not like other stuff. And this combination of fascinating and challenging makes it, and also the criticality of it, the fact that um, it is something that we use to protect, that we use to secure our stuff, makes it very critical. And the fact that all of our lives now, all organizations are now internet connected, it makes it very, very, very important. So let's get started. I'm going to uh, open hack the box. Okay. So if you go here, hack the box, you make an account. I have an account already. And once you log in, you I mean, actually, let's just follow along, okay? Like, just watch, and I'll give you the link and then instructions if you want to repeat this machine on your own after. Okay. Uh, so let me start this. And again, if anything doesn't make sense, that's meant to be. Like when we get started, no worries. We're just here looking at, just as we showed in the diagram. We're just looking at something up here, okay? And we're trying to give you an idea here. And there's so many gaps in between, but that's okay. So right now, let me do. Right now, I will try to narrate my workflow, my process, and like just like watch and keep any questions to the end. Okay, we'll make it very quick, and give you an idea of the whole process. It's actually, zoom in, please. Uh, okay, 1 second. Okay, for the hand. Okay, in the terminal, sure. In the terminal, sure. Okay, clear. Okay, I'll be opening a tool called Cherry Tree. It allows us to take notes. Okay, and I will use it for note taking because it's important that you document your whole process while pen testing. Um, I'm gonna create a node. How can we increase the font here? I think I'll keep it as is. Okay. Now from this second onwards is going to be more fast paced and it's going to be meant to give you that idea. We can have sessions in the future to go more in depth, more in detail, but because of time constraints, this is just going to be that overview, that high level overview of the whole process. Okay. So now I'm on Hack the Box. Let me actually, it's on my other screen. So let me launch a box. So what we will be taking is going to be an IP address, okay? And we're going to take that IP. It's the logical address of a machine on the internet. We're going to be taking it and trying to enumerate it and eventually get into it, okay? Hack it. So let's create a node to document. So it's going to be enumeration or information, okay? And I'm going to say IP. That's the IP that's the IP I received, okay? So we're starting from just one IP. Let's see if we can bing it. Okay. And again, I'm gonna be super fast. So let's bing. Bing is a tool we use to detect if we're if a device is reachable on the network or not. Now it doesn't seem to be reachable. Why? Because 10.10 is a private IP address. Okay. Private IP addresses can't be accessed. Let's see this. Private IP addresses cannot be accessed over the internet. Okay. So what do we need to do? We need to connect to Hack the Box's network. How do we do that? We do that with VPN. Now I'm gonna be fast, so don't worry. Like no need to worry. This is intentional. So I'm gonna do connect to VPN using a tool called OpenVPN. And right now let's do this. It's gonna be at HTB machines. Yes, I'm gonna type in my password, and here we go. Now again, here we're getting this kind of scary stuff, but no worries. But what we care about is we got this. We have connected to the VPN, and if we look up here, this used to say, if I could actually close this, this used to say no tunnel, okay. But after we ran this command, yeah, here we go. We received an IP address 10.10, so we are now part of that local network thanks to the VPN. So we're now connected the to the hack the box network. So let me actually, I'm gonna make a directory. I'm gonna name it the name of our machine. So it's gonna be Cozy Hosting. Okay, that's the one we're doing today, and I will be working from here. And let's zoom in a little bit. Okay, so now if we bing, let's see what was the. Let's ping that IP. That's the IP of our target. Here we go. Now we can bing it, and we're connected to it. So now what? After binging it, let's see what's running on that device. Okay. Let's see what's running on this device. You see, penetration testing or hacking is all about collecting information. The more information you have, the more leverage, the more you can do. And most of our work is going to involve that. So we started with just an IP. Let's move here. We started with an IP. Okay. And let's see what can we do from here. Okay. We want to get more information. So we're gonna scan it. We're gonna scan the services offered or opened on that target using a tool called nmap. So I'm gonna do nmap. I'm gonna type in the IP again. It takes in the IP. It takes in the IP, and it takes in some flags. These flags indicate, or these uh, switches, they indicate what we want to do with that tool on that device. So I'll be doing dash b dash. I can do, for example, um, I can scan the top like one. I can scan from 1 to 1,000, for example. Okay. And I can do dash SV. Let's actually see what this gives us first. I'm gonna do dash V to get our results right away. I'm gonna do that, and here we go. It's discovering open ports on that target and it's scanning them. Let's wait for it for a few seconds and see what it gives us. Okay, here we go. It detected two ports, 22 and 80. Okay. Uh, Usually, what we would do is we would scan all ports using something like this, dash B dash. Okay. And once we scan everything on this machine or in that device, we will start looking at each port one by one and see if that port is vulnerable, if it introduces a vulnerability or not. Okay. Are we good so far? And again, high level. So, okay. Okay. Now what we're going to do is now actually, let me have a look at something. So, because we don't have time to scan all ports, let's do, yeah, I think this box doesn't have more than two ports. So usually we would do all services, but for now we know that this box only have 22 and 80, and we scanned these. So let's now do 22. Now that we identified these two ports, let's actually copy them to our notes because we're trying to be organized. So um, open services or open ports here, okay? And let's make this maybe like colored or something. Can we do that? I don't. Okay. Okay, let's make it green. Okay. Okay, so now we have the open ports and we have, okay, we have the IP and we found some open ports. Now let's see what is running on these ports because maybe these are some TCP ports. Now you see how networking is something that you need to have before we delve into this. But again, we're doing the reverse learning thingy. Let's start scanning this. So I'm gonna say that 22 and 80. I want to perform a version enumeration to detect the versions of the services running here, and I want to run some default scripts on them. Okay, these two flags, we can find them from the nmap documentation, but that's another like a topic for another day. And let's do dash vv, and let's save the output into nmap results. Okay, that's something I would be doing, and .text for example, or I think it does well. Okay, so let that run again. Now it's not gonna just discover them that they're open. It's gonna do more stuff. It's gonna see what is happening on these ports, what services are being run. So you can see here after it performed the scan and discovered them, it's doing other stuff. It's doing scanning the services and it's trying to do more like sophisticated scans to determine what is exactly running on these. Now we're just using the tool. We don't really know how it works. We can't really write one that's similar to it at this level, but that's something to think about. That there's people who are actually um, advanced. They can write these tools and make them, and they know how to make this work using, of course, programming. So we have it's where we're almost done, but we have some results here. It's saying that this is 22 TCB, that's SSH, and it gave us the actual version running on this. It's OpenSSH. Just actually do this. Just copy this because we're all about collecting information. So let's let's say that we investigated board 22, and this is what we found. Can we insert some code snippets? I think this is the one. Okay. Or do we? I don't think we need to. But anyways, we can do this. And okay. So now port 22, we can type something. So it has SSH running. Now if we know SSH is a service that allows us to connect remotely to a target. Now, from experience, I wouldn't attack this because I know that this is usually like outside the challenge. It's usually secure. This version is secure. It's nothing to attack unless I have a username and a password, which I don't. Okay. So I'm not gonna bother with this, but I'm just documenting what's running here. So let's move on to the next one, port 80. Okay, let's see what's running here. Okay, it says that this is, oh, this is Nginx. It's HTTP. Okay, so it's a website. Okay, that's nice. Let's see what this website has to offer to us. So let's start opening this in a web browser. So let's copy the IP again because that's our target. Now we're interacting with that port 80. And what happens? It seems that we were taken to this domain, CozyHosting.htb, which is not an actual domain. So we need to add it to our local DNS. Okay. So I'm going to do sudo vim/etc/hosts. Okay. And I'm going to add in the IP and I'm going to add CozyHosting.htb. Okay, WQ. Okay. So now if I refresh, here we go. We're presented with a website. Okay. Now again, penetration testing is about collecting information. So now that we see this website, we need to like figure out what does it do, what's exactly on it. So maybe one of these things that we can do on this website, maybe it's vulnerable. Okay. So I'm gonna do the most basic thing possible. I'm gonna just explore it manually. So let's look at these, like hover over the links and see where they take us. You can look here and you can see, oh, this one is the /login page. Let's see that. And there seems to be some login functionality. Okay, that's cool. Let's move down here. Okay, there seems to be nothing else. Let's, what we're gonna do is let's actually try scanning this website. Let's see, like maybe there's login, maybe there's something else. So how can we scan this and automate it? There's tools to do this. Like if we wanna try different pages, login is a page, but like we wanna know what else is a page. Okay. Oh, there's something interesting here. We'll get to that later. So we can use a tool like FUF. Okay. Let's actually not do, how can I, okay, I want to disable this because it's spoiling the thing. Anyways, we can do something like FUF. We can do HTTP CozyHosting.htb, and we're going to give it the place where we want to brute force, or the place where we want to discover things. So we want to discover things here. Like instead of this word, we want to discover things, other pages here. So we're going to give it that, and we're going to give it what we call a word list. Let's control that. We're going to give it a word list. Okay, a word list is just a file with so many text and so many different options that we're going to try. So user share word lists, and I know what word lists I have on this system. So let's try one of them. I'm going to use discovery web content big.txt. It's a good word list. I'm going to do -c to make this colored. And here we go. Are we discovering anything? Oh, here we go. Something just popped. There's a page called admin. Let's check that out. Oh, so when we went to admin, it just keeps like it loads and then takes us back to login. So we don't have access to that. But at least we know that there's some admin functionality on this website, which is like a good thing to know of. Okay, because maybe we can hack that. But we need some credentials. We need a way to get into this website. Um, let's look at this. There's a page called error. Okay. It seems to be an error message from some framework or some technology that's running on this website. Let's maybe search that up. Okay, so there's people. Oh, There's someone who's saying that this error message is related to Spring Boot. Spring Boot is the technology, a web technology that's used by Java applications. Okay, so from research, so we took that error message and we researched it, and we found that there is some Java framework running on this application. So that's some good information actually. Okay, so let's like update our mind map here. So we found 22. We found from the IB, we found two ports. We found 22 and we found 80. Okay, 80 is HTTP. That's a website. Okay, 22, we know that it's not gonna have anything. We eliminated that and we pursued 80. Okay, 80, after pursuing it, we found that it is a web server. Okay, we scanned that and we found like this web server. We scanned it, and sorry for the drawing. We scanned that and we found a couple of things. So we found admin slash admin, and we found, and by the way, like if this totally makes no sense to you, that's very, very expected. I'm just giving you a very, very like we're jumping steps here just to show you the picture. Okay, so slash admin slash web, and we found slash error. Okay, and we found slash login. Okay, now admin, this was inaccessible. We didn't have access to admin, but error allowed us to gain some information. Error told us that this is a Spring Boot application, and Spring Boot is a special technology used to make web applications. So now we're getting information about our target. Okay, we could update this here. So okay, found Spring Boot to be running. Okay, so and in a real report, you'd be providing, of course, more details and something that's more technical, and people will be looking at it, reading it, and trying to use it to fix and secure their devices or the networks or whatever. So let's take this further. Since we have or we know that this is a Spring Boot network, or Spring Boot, or there's Spring Boot running on this device, let's try to search for things that are specific to Spring Boot. Okay, because now that we know it's running, we're not going to use something like big.txt. We're going to use some other word lists, some other file that contains strings related to Spring Boot. So let's see. Thankfully, this sick lists offers us that precisely that. So I can do Spring Boot, and there's actual word list here for Spring Boot. And if we look at it, it's going to have lots of URLs and like directories that are related to Spring Boot. So let's do that. I'm going to do enter, and boom, here we go. So it has only 112 entries, and we looked at all of them, and these 112 entries are specific to Spring Boot, and we found these stuff, and we're going to look at them. But what you notice is we used one knowledge from one area, and we can see that we used one knowledge we discovered here to perform an action to discover even more knowledge. So let's do here, and we can do scanned for Spring Boot files or URLs. Okay, found stuff. Okay, and we're going to look at these stuff here. Okay, so these are our stuff that we found. Let's copy them actually because they're interesting. Scanned using Spring Boot.txt, which is our word list, and we found these stuff. Okay, now let's take them one by one and see what do we have. I'm actually interested in this one, or we can maybe copy this one. Like let's here we go. So paste. Okay, so it seems that we're getting some data here. And this data, I'll tell you from experience, it's just all the different things that you can do on this server, and they're exposed to us here. So you can look at them and like review them for like things that are interesting. I'll be interested in something here called sessions. I'll be interested in that. Let's look that up. Oops, refresh. Let's look that up. Nope, not in Google. We want to look that site up. So I don't want to search that. I want to do, okay, yep. Here we go. So when we look that up, it seems that there's a couple of sessions here. Two of them are unauthorized, and one of them belonged to a user called K. Anderson. So let's take this code, and sessions in the context of a web application, they identify different users. But now this IB is giving me the sessions for everyone. So if I take this ID, that code, I might be able to impersonate this person. So let's actually do just that. So I'm going to do Control Shift I to open the developer tools. And then I'm going to come here into my cookies. And if we look, it seems that I have some cookie here called J. Can we? I have a cookie here called J session, and it has some value. Let's try and replace that with the one I just obtained for K Anderson. Okay. And before that, I want to show you something. If we go cozyhosting.htb, because get started, can we log in? Okay. Now that we actually replaced this with our cookie, we gained access to this person. Okay, we gained access to admin. Let's actually like remove this, and let's I have this copied, but let's go here. Right now we have a login button because we're not logged in. Okay, because our session, the one we have right now, it's empty. It has nothing. If we refresh again, maybe, yeah, it's empty. We don't have any value in here. We don't have a session. We're unauthorized. But if we now using that vulnerability that we just saw, which was this, the fact that we're able to see everyone's session. Okay, this is like sensitive. We found this information here. We can actually screenshot this and put it as evidence in our report, our sudo report, and say like investigating actuators / sessions. We found all session IDs exposed. Okay, so we pasting that, and now that's evidence. Hopefully the person reviewing this report will understand. And here we're gonna take this copy and we're gonna use it here. Like now we're impersonating that person. We're putting his session to be our session. When we press enter, now that's gonna be our cookie. And if we, let's actually close this. And now if we go to the home page, you see that the login button just disappeared because now we're logged in. And if we go to /admin, we do in fact have access to as K Anderson. So now what we just performed was called session hijacking. Okay, we hijacked that person's session. Okay, and even without a password, we don't know his password yet, even, but we were able to steal his session. Are we cool? Does any of that make any sense? Okay. Again, high level overview, quick, advanced, just to get an idea of the whole process. There's so many things I'm skipping. Can you try doing that on Netflix? No, they're probably secure. Pinging allows you to communicate. Okay, nothing, no questions for me. Actually, I don't know. Can someone raise their hand? I want to know if I get a notification. Okay, I do. So if there's something that requires my interaction, raise your hand. Okay, so now we can perform session hijacking and log in as K Anderson. Now this is not enough. Like we're not done yet. We still don't have any code execution or anything on this box, and we'll get to that later. Let's actually first document this. So I'm gonna do here and like show the people responsible for this website that we were able to break in there, like show them that this is actually severe. And like so even like type something. Boom. Okay. So now we're into their super secret admin dashboard. Now let's explore more. So and let's update our drawings. So uh, actually, let's not update our drawing because it's gonna take time. Let's keep this like only this is gonna be our notes from now on. And then we're supposed to use this like do different notes, but uh, I'll keep it like I'll keep everything in one file for now. Um, so let's but we can make it more organized and add stuff. So like sub notes, for example. And now we have a sub note and we have information and we can organize things that way. But anyways, so now let's look at this. Now we're gonna inspect this dashboard. So now we gained access to more information. Now let's use that new information to find more, even more information. It's a recursive process. We keep doing that over and over again. So let's explore this. What's going on in this page? There seems to be some sales. It's a dashboard for sales. There's some graphs. There's some money involved. There's things that are batched and non-batched. I don't know what that is, but like there's no links. But oh, there's something very special here. Include host into automatic batching, connection strings, and username. Okay, let's see what this does. So, like, what happens if I do like local host and like username and submit? Host key verification failed. Oh, there seems to be something going on in this. Like, there's some code that you or like some function that is being run when I click submit. So let's investigate this more. Let's try something else. So like, oh, okay. Now, what we just did was a common thing that we do in security, which is you, you literally smash your keyboard, type anything, and see if the system behaves in unexpected ways. Give it some weird, unexpected values and see what happens. It seems that whatever we run here, there's a command SSH that being run on the target that tries to run using um, your input. So let's actually fire up a tool to test this even more clearly. We're going to use something called Burp Suite. It's a web application security tool that we can use to intercept and repeat requests. Okay, it's used for web security. Again, that's a whole different topic. We're doing a quick overview. So let's see. I'm going to come here and I'm going to set my browser to send things to Burp Suite. Okay, and I'm going to send here some host and some random input here because I want to investigate what this looks like. I'm going to click submit, and I actually should go to here and I should enable interception. So Burp Suite intercepts anything that gets sent to it. Let's repeat that again, and I'm going to type in adham, submit, and boom. Once we submitted, this was received by Burp Suite, and we can see the request, how it looks like. Now we literally stop the request midway before it goes to the server. And if we look at the server, it is still loading because it's waiting for the response. Okay, it's still waiting for the response. Now I'm gonna if I decide to forward it back to the server, then and then forward that again. If we go back, now the server has loaded and it received the response. So we're in the middle using Burp Suite. We're investigating or analyzing the requests and controlling them before sending them back to the server. Let's do that again one more time. I'm gonna submit. Now it's intercepted, and I want to send it right click, I want to send it to something called repeater. Okay, it is sent to repeater. Repeater allows us to send requests over and over again. And you can see that the cookie JSession ID is still in here. That's the same cookie we used to impersonate K. Anderson, that guy. Now, if we do control space, can we send this? Okay, it's a redirect. So let's come here and say something like follow redirections always. And now we can send that again. And here we go. We're getting some output. Okay, let's come here. Where is, okay, this is the, so let's keep searching for this. I want to search for this alert, or like maybe search for this. So like I'm going to copy this, I'm going to search for it, and I'm going to say auto scroll when the text changes. Now I can send over and over again, and it's going to bring me to this area where the where we can see the error message clearly. Okay. So now I can experiment here. I can try different things. Let's see if my intuition is right. I think that this server is taking whatever we give it and it's running it in a command, an SSH command. So let's try putting we're trying to execute code on that server. So let's try to do some, okay, bad requests. Why is that a bad request? Can we, maybe is it testing for semicolons? Let's try maybe, can we do something like this? Who am I? Failure, temporary failure. Let's see what that looks like. We're trying different things and we're trying to get to a point where we execute code on the target device. Okay, so let me have a look here because I have the payload. Let's try to do something like this. Let's do just semicolon and see what that looks like. It's still a bad request. Can we not follow redirections? I want to see. Never. Control space. Here we go. When we send this, we see some error message returned, okay? And this is telling us so much. Let's actually try and like mimic this on our machine. So let me try to do SSH. What is happening is semicolon at host. What do we get? We get the exact same error message. We're getting usage, SSH, whatever, and then command at host is not found. And this is precisely what we just saw here. Okay. Does someone want to join? Did he join? Okay. So now that we have some understanding of what is going on here, let's try and get this to work. So right now we have this. This is the username. Let's try and model it a little bit. So we have the username and host. This is the command that's being run on the server, and the username is here and the host is here. Okay, and we have control over the username and we have control over the host. So how can we get this to, like, we want to escape this command. We don't want to run SSH. We want to run our own code. Okay, so that's precisely what we're going to do. If we put a hashtag sign here, okay, we're gonna ignore or comment out the next part, okay? And if we do 2/dev null here, we're gonna remove the error message given by SSH. And if we put a semicolon here, we can start writing our own code in here. Okay. I hope that makes this probably doesn't make sense. But anyways, if we take this string and send it or write it as part of the username here, then we might be able to escape this SSH and run any code we want. So what's happening? Slash bin slash bash. Who am I? At host command not found. Uh, let's try and URL encode this. So Control U. That wasn't the issue. Let's try and like maybe add a space here. Here we go. Okay. Username can't contain white spaces. There's a trick we can use to encode white spaces, which is command cannot be found. Who am I? Okay, so I guess we need a space between. Here we go. So what we just did, and I think we could also use semicolon here. Yeah, what we just did is now, like we escaped this SSH, we ignored it completely, and we're now able to run something on the server. But we're still unable to know or like get the output of that command. Could we possibly do? Um, can we do this? I think it could be possible. Here we go. Yes, we can. So it seems that this error message, it just shows you things that are part of an error message. So we redirected our output to the error stream, which is 2, and that's how we got our result here. So now we can run any command and we can see the output here. So I can do host name, and I get some output here. Okay, CozyHosting. Let's try and see if we can Bing ourselves. Okay, so I'm going to do Bing, and I'm going to put our IB, this one. So let's copy. I'm going to do -C 4 to Bing 4 times. And then I'm going to put 10.10.14.192. Okay. Now, before that, because I want to confirm if I can write that code or like if I can receive these pings, I'm going to do sudo tcb dump, and I still have the command to listen on the network, on this network, for any Bing requests. Okay. So now that I'm listening, let's send this and look here. See if we do receive anything. Oh, we're receiving stuff. So we now confirm that in fact, we're able to receive or send or execute code on the target machine. And we were able to Bing ourselves back. Okay. Some other way I could do this is using sleep. So I could sleep here, and I can say like sleep for 5 seconds and send this. And you can notice it's waiting, it's sleeping. And okay, so now I can confirm that indeed I'm executing code on that target machine. So now let's take this a step further. We have 2 minutes and get code execution on this device. So I'm going to start listening using netcat. I'm going to start listening on this port. And I'm going to do what we call a reverse shell. Okay. So I'm now that I have code execution on this target, I'm trying to get it to connect back to me so I can start controlling it remotely. So it's actually going to burp suite. So let's disable that. Refresh, rev shells. And I'm gonna do bash. I want a bash reverse shell. And I'm gonna copy maybe one of these. And I'm gonna come here. Oh, I didn't update my IP, so let's update my IP 10.10. This tool helps you or like lets you generate reverse shells quickly. So I can copy that. Can we have some encoding? Okay, I don't want to encode it. And I will come here and insert that instead of the sleep. I will put it here. Let's actually first, like, I want to document this. Uh, we gain code execution using the following payload, and we put that here. Maybe you can even like make this a code block. Here we go. And now let's copy the reverse shell again and paste it here instead of the sleep. And let's encode, or like instead of spaces, because spaces are not allowed, let's put this. Now, should this work? No, it didn't work. Let's actually, we need to URL encode most of this. So or maybe so there's some characters in that string that's preventing us from executing our code. Okay, I think the simplest way we can do this is we can take all of this and encode it into base 64. Okay, and what we're going to do here is, instead of this, I don't remember. Yeah, I think that was, yeah, that's okay. Now we can do paste this, and I can do something like echo ifs. Let's actually separate this so I can see what's going on. IFS, and then I'm gonna base the base 64, and then I'm gonna base 64 again, and oops, IFS, and then I'm gonna do dash D to decode it, and then I'm gonna pass it to bash. Delete. So let's do this and do that, and now I think if we run this, we should get some code execution going. Oh, it hanged. That's a good sign. If we go here, boom, we have code access to this machine. So I can type stuff, who am I, ls, and that's how we got code execution in this machine. Anyways, okay, so now that we have this user access, we have a reverse shell, okay? Let's see what can we do. Again, it's very repetitive. You get information and you use that information to find more and more information. So from this, we could achieve like very small code execution, like who am I, sleep, Bing, whatever. But now that we were able to get a complete, fully fledged reverse shell, and let's actually copy this payload because we want to like have it in our report, or like in our notes at least. Can we actually change this into, oops, execute code? I don't know, how can we, okay, okay, we can change it here. Okay, so now we have some syntax highlighting. We can do this. We can we increase the, I don't know if we can increase the font. Anyways, now that we have a better, fully fledged interactive shell that we can type in, let's start moving. I can look at the different services running inside this box using this command, and we can see, in fact, that there is, I can see these ones at least. These are, I believe they're done by other users who are hacking this box at the same time. So let's not look at these, but there are people hacking it, and we can see their shells. They're trying to get access. And if we look here, we can see that there is something running locally. Okay, it's running on local hosts, 5432. And from experience, we know that 5432 is a Postgres database. Okay, there is a database running here. So my intuition would be to look at the application, this application that's running, and see if there's some credentials that help, like probably this application is connecting to the database. Okay, now this application, there's a file here. So let's look inside. Maybe there's some credentials we could use um, to look in this database. So what I'm going to do is I'm going to let's see the cozy hosting again. What I'm going to do is I'm going to make a directory called uploads, cd uploads, and I'm going to do Python 3m upload server. There's no module, so I'm going to install a module called upload server to help me upload things because I want to get this uh, file, jar file, I want to get it to my Kali machine. Okay, so I inspect it further. So I'm gonna do Python m upload server. It's running on 80. Yeah, we can. Okay, you can keep it running on 8,000. Now it's listening. Let's transfer this file to my Kali machine. Okay, can we zoom in a little? So I'm gonna do curl. I'm gonna do xpost. I'm gonna do -f for file, and I'm gonna do at to declare a file again, and I'm gonna do cloud hosting 0.0.0.1.1.jar. Okay, and I'm gonna specify the server I want to hit. In this case, is gonna be my IP 10.14.192, 10.14.192, and I'm gonna hit port 8000. Okay, now if I do this, I suppose this should work, and I would be able to upload things to my. Oh, and I forgot to add the path, so I should do /upload. So I should be able to transfer this cloud hosting. Hopefully, I typed it correctly to my Kali machine. Enter. There's some command f-f is used badly here. Why is it used badly? Let's look at upload server Python. Let's look at its documentation and let's see how it's used. Okay, so you have to specify files. Okay, which is okay. So I'm gonna do files equal at cloud hosting. Let's actually copy everything here. Okay. Okay, so it's loading. Things are getting uploaded. It's a 57 megabyte file, so it makes sense. And if we go here, I think, no, okay, we don't get anything yet, but let's wait. Hopefully, I think if we do split this vertically, we can cd into cozy hosting. We can cd into uploads. Yeah, okay, so there's some temporary file being loaded. And I think we could watch -d -n 0.1 ls-la. Oh, so it just completed. Okay, it's sent fully from our target, and we received the request here. It completed, and we can see that now we do have the file. It's no longer a temp, it is the file. So now let's analyze this. Okay, we do have JAD. Okay, never mind. So I can do open project files, and I can do cozy hosting, uploads. We want to open a file, so let's go home. I'm gonna do cozy hosting, uploads, cloud hosting dot jar. Okay, same warnings are showing. Okay, here we go. So now let's look at this. Let's look at this some Java application source code. So let's look at it. Maybe, okay, here we go. I know from experience that application.properties in this directory usually contains like things like database credentials. So I'm gonna come here and I'm gonna look at this. There's a password. So let's copy this or maybe take a screenshot. So there's a password for the database. Okay. So let's copy this, add it to how can we okay. We exfiltrate the .jar file, we decompile it, and we find database password. Okay, so now with the password, what do you think we should be doing with this password? Let's try and connect to the database. So here, let's see if we have PSQL. Okay, we do have it. Let's see Postgres at localhost. Can we do that? Role app does not exist. What can we? Okay, this is the Postgres. I'm not sure what is the. Let's look at this. PSQL dash dash help. Okay, so we do dash h for host, dash u for the user, capital U. So let's do PSQL dash host. I want to do this, and then capital U Postgres and the password, which is what we have here. Copy that, and let's put this between single quotes. And okay, didn't. Okay, W forces password prompt. So let's paste the password in here. Database. Okay, so it treats this as the database name. So let's do this, PSQL, copy that, and I'm going to type in the database name, which is here somewhere. Okay, that's the name of the database, Postgres SQL. So Postgres SQL, is that right? Yep, enter. It's asking for the password. We're going to copy that and paste it. Database does not exist. Did I type it wrong? Is it CozyHosting? That's the name. Maybe. Maybe you can just do this without declaring a database. Yes, I think that worked. Did it? Okay, it did. So we're now in a Postgres prompt, like we're interacting with the database. Okay. So let's look at this. Let's connect to CozyHosting. That's the name of the database. It's asking for the password again, so let's paste the same password. You're now connected to the database CozyHosting as user Postgres. Now let's do -L, -DT, I believe. Okay, to look at the different tables in this database. There's one called users. Let's look at it. Select all from users. Now we're typing SQL, and here we go. We have a couple of things. We have one for K. Anderson, and we have one for admin. I would be interested in this one for the admin. Actually, we can take both. So let's copy this. Go back to our Kali. Let's exit this. Let's actually cd. So I'm gonna do vim hashes. I grab these hashes, okay? So let's put them this way so we can crack them. We want to crack them now. So I'm going to do -WQ, or let's actually give them names. So first one was K. Anderson. Second one was admin. Okay. So I'm going to WQ. And I don't yet know like what type of hashes are these. So I'm going to we're going to be using hashcat. So let's go to hashcat examples. Okay. And let's look in the examples. This file, like it has, or this page has so many examples of hashes and what type they are. So let's look at this. Cat hashes. They all start with this 2A. Let's copy that and see if we can find them here. 2A. Okay. So it seems to be bcrypt blowfish Unix. Does that look like ours? 2A05. Yeah, it does look like ours. So it's probably this is the type. Okay. So let's do hashcat. Let's try cracking it. So I'm going to do hashcat -m. I'm going to paste in that number. That's the type of the hash. And I'm going to do hashes, the name of the file that contains our hashes. And I'm going to do user share wordless /rockq, okay, to start cracking these. And I'm going to do -- username to say or tell hashcat that the hashes have a username before them so it doesn't get confused. If I do enter now, hashcat, the tool is going to start, and you can see here my CPU is like there's some increased load, but it's going to start. Right now it's initializing the CPU. Actually, it didn't start cracking yet. You can see some action here going. CPU usage. And we started cracking. We can do interact with it using S for status. And we can see it's running. And we can see the utilization, CPU utilization. And we can see that, and I can actually hear my computer screaming. So it's 85% right now. And let's see if estimated time is 3 days. Okay, we're not going to stay for that long. But eventually, and hopefully, it starts cracking something. So let's wait. It's trying different names, different things, and hopefully we'll get the password for one of these users. Oh, we have some result here. One of the passwords was cracked, and the plain text is Manchester United. Okay, I'll take it. Let's copy this, and let's actually make a new terminal here. Okay, that's interesting. And let's do CD CozyHosting. I want to know which one was this for. So cat hashes. And this hash was SP and Manchester United. Oh, it belongs to admin. Okay, that's nice. That's nice. Let's go ahead and save this in our. We connected to the database. We found this credential for admin. Admin user. And let's actually take a screenshot of the database. Okay, that's a big screenshot, but anyways. And dumped its credentials. Okay, so now we got this credential. Let's try and do something with it. Let's see if we can use it to do anything on this system. Quit. Bye. How do we? This is, I think, Postgres. How do we exit Postgres? Are we still in here? Yes, we are. I think it's dash Q. Yep. So now we can clear. And now let's see if we can use these credentials anywhere on the system. So let's look at the different users we have here. Okay, there's one called Josh. There is root. Let's try to connect root because it's an admin password. So let's do sudo or su root. It's asking for the password. Let's type in Manchester United. Oh, it didn't work. Let's try Josh. So SU Josh, Manchester United. Does that work? I have a feeling it did. Oh, it did work. So now we are logged in as Josh. Let's see if we have Python 3. So let's do import pty because I don't like when my terminal is hidden this way. And we can do this. And now we are here. Okay. Who am I? I'm Josh. So we moved from being just Ab. We were at a user called Ab. We're now a user called Josh. So let's cd into Josh into home/Josh. And let's ls. And here we go. We have access to the user flag. Can look at it and I can submit it to hack the box. Okay. So we got the first flag. There's two flags in this machine. One is the user flag and one is the root flag. Now to get root, we need to become this user, root. Okay. Right now we are Josh. Okay. We moved from Ab, which one is Ab? There was which user? Yeah, this user app, which was responsible for the web application running CozyHosting. Once we logged in and hacked that app, we were user app, and then we moved to Josh, and now we want to move to root. Okay, because we want to gain more access, more privileges. Um, and again, we're ignoring this guy because this is like unintentional. This is like someone else was doing this machine with us. He added it after he finished it. So he's ruining it for all of us. But anyways, how can we get through it? Let's try do sudo dash L and let's try Manchester United. Oh, so sudo dash L, when you do it, it shows you all the commands that the admin of this machine let you run intentionally. Right now, there's a tool, bin ssh, which we can run using this format as root. But this doesn't necessarily mean that we get root access, except if we go here, there is a website called GTFO bins, okay, .github.io, and we can use it to search for different ways we can abuse these tools when we find them, okay? So let's type SSH, and let's see the tag. So it says shell, file upload, file download, file read. So you can abuse it for these things. And if you have sudo access, you can abuse it to get an interactive shell. So let's look at this. Spawn interactive shell through proxy command option. That looks nice. Let's copy this. And let's do ops. Okay. Why do we get okay? Because first I want to type sudo. Okay, it's for some reason I think it's a coloring. If does it happen if we do this? Okay, never mind. It's unrelated. Paste clipboard. Okay, that's annoying. Sometimes when you're in a shell, like when you type use the arrow keys, or like, okay, at least I can use Control W. Let's actually type it. So I'm going to do sudo ssh-o proxy command. So ssh-o proxy command equal, and we're going to type in this. So semicolon sh semicolon sh and then 0 and okay, 0 and 2, and then 1, yes, 1 and 2, and x. Now if we run this, we should gain root. Enter, and here we go. If we type in who am I? I'm root. If I cd into slash root and ls, I can see the root flag. And we can submit this to Hack the Box. And let's actually take a quick save this. We find out this password is used by Josh. We sue Josh, and then let's actually put this into a code block. Any questions?